My name is Todd Lipcon. I've been at Cloudera for 17 months now. I started beginning of last spring. I've been working on Hadoop for a bit over 2 years, actually. My first patch was in May of 2008. So I've been using it for a while, and I've been through a lot of versions, and it's coming a long way, and I'm excited that there's so many people interested in it. In terms of HBase, I started getting heavily involved in the HBase project about 4 or 5 months ago, though actually my first patch to that was also in 2008, so I've been around for a while, and recently became a committer, working pretty much full-time on HBase and HDFS. Okay, so first we're just going to start off with a bit of an overview of HBase. It sounds like probably most people here know what it is. You didn't just hear there's a term called HBase and sign up for training. So we'll go through this reasonably quickly so we can get on to the more interesting stuff. So first, a little overview of this chapter. We'll cover what HBase is, what separates it from things like relational databases or Hadoop in general, HDFS. Next, we'll cover some usage scenarios, some typical use cases. Why might I need HBase instead of these other systems? And then talk specifically about these comparisons. So in terms of what HBase is in general, the one sentence summary is that it's an open source, distributed, sparse, column-oriented store modeled after Google's Bigtable. So now we're done, you can all go home. So to go over each of these bolded words one by one, open source, it's Apache 2.0 license, which I think is very attractive for a lot of organizations. There's no GPL virality to it. You can integrate it in your products. You can use it however you like. It's distributed, meaning it runs on a cluster of commodity machines. This differs from a lot of the proprietary databases which require InfiniBand or other special interconnects. It's just normal commodity hardware, giggy, things like that. By sparse, we're going to get into the sparse column-oriented bit a little later in the day about the data model. Essentially, sparse means that any row doesn't necessarily have a strict schema of here are the 5 columns in the row. A row can sort of be, you can add new columns almost as if it were a map or sort of a tag and attribute value pairs. Column-oriented, this means that generally that you have some control over how the thing is stored on disk. And if you want to be able to say that this column is never accessed with this other column, you can make sure they're stored in separate files, which can help with the access patterns. We'll also cover that more when we talk about schema design later. And then it's modeled after Google's Bigtable. Bigtable is a system developed at Google starting in 2004 and deployed in 2006. There's a Bigtable paper from OSDI 06 that I encourage you to read if you like reading academic papers. Almost one-to-one mapping with the concepts in HBase. So in terms of usage scenarios, these are some of the reasons why you might be looking at HBase. I imagine most of you guys probably fall into this camp. One major reason is that you have a lot of data. So relational databases work really well for small sets of data. I would never consider using HBase if I only had a gig of data. It's probably not worth it. So if you have hundreds of gigabytes, terabytes, up to even petabytes of data, HBase can scale to that, whereas a typical relational database can't. Another reason you might look at it is if you have very high write throughput. The design of HBase, in terms of how it stores data, is modeled so that writes can actually be done entirely sequential. It only does sequential I/O for writes, and that means you can get very high throughput. So the typical throughputs, it's hard to put a number, just in a presentation. It depends on the size of your rows and the hardware you're running on. But you can expect thousands of writes per second per node, and you can scale up the number of nodes to the hundreds, so you can do millions of writes per second and not worry that your system is going to fall over. You're probably going to be network bound on most hardware. Another great selling point for this is because it's distributed, it's very easy to scale the cache capacity. So you might have a pretty small data set, maybe only 100 gigs. And yeah, you can get 100 gigs to run fine on an Oracle instance or even a MySQL instance. The issue is that buying a machine with 128 gigs of RAM, you can do it. It's not that expensive. But when you restart that instance and you have to load everything back into the 128 gigs of RAM, you're going to be hitting a cold cache for days probably, and it's going to be really unperformant. So the ability to distribute across a number of machines, each machine might have only 24 gigs of RAM, but you can have 100 machines, and all of a sudden you've got 2.4 terabytes of RAM, which you're certainly not going to get on one machine. The last bit is the data layout. The data layout, as we'll get into more, is stored so it's very, very efficient for key lookup in terms of the number of disk seeks. So in a lot of scaling applications, the number of disk seeks is the limiting factor for how fast you can do random reads. And HBase is very good because it's, for one, it's efficient, and for two, it's cost transparent. So that's a concept that some of you may not have heard of, but it's I think one of the really compelling things about HBase is that when you do an access, you know exactly what the disk heads are going to do for that access, and you can actually plan out that I'm doing a read and it's going to do 3 seeks. Whereas on a typical database, it's very, very hard to understand exactly how many seeks each operation corresponds to, which is harder for capacity planning. It's harder for deciding what your latency windows are for SLAs, things like that. Another thing about the data layout, as I mentioned, is that it excels for sparse columns. So if you have some data that's maybe semi-structured, rather than fits into a nice relational model, it's okay that some rows might have data filled in for some columns and other rows might not. And this gives you a lot of flexibility for the data model that you might not have in a relational database. So going into the specific comparison of HBase versus relational, it's hard to just say relational database is X because there's so many of them. There are different families of them. There's analytical relational databases. This one is sort of geared towards the MySQL family, MySQL Postgres, more than others, but a lot of the comparisons make sense across a wide range. So the data layout, as I mentioned in HBase, is column-oriented. It's not truly column-oriented like a database like Vertica. It's somewhat of a hybrid. So we're going to cover that as we talk about data model later. But essentially, on a relational database, each row is laid out column A, column B, column C, and then you go to the next row, column A, column B, column C. Whereas in HBase, or columnar databases, you have all of the column A, and then all of the column B, and then all the column C for the entire table. And the advantage of this is that if you want to just access one row, you don't have to read the data for the others. In terms of transactions, this is one place that HBase does not choose to compete. The transaction capability is essentially on a single row basis in HBase, and it's not even full transactional like ACID compliance. It gives you some primitives, which we'll talk about later in the day, that allow you to sort of simulate transactions on a single row basis. Whereas obviously most databases have full ACID. In terms of the query language, most relational databases expose SQL. It's very common, everybody knows it. HBase doesn't. There's a little bit of an asterisk there, because you can now integrate HBase with Hive in the latest version of Hive, and actually perform some SQL queries on HBase, but they won't be real-time queries. They'll be analytical, several-minute data warehousing type queries. So the API that HBase does give you is these 3 things: get, put, and scan. And these are essentially single row, get all the columns or get some subset of the columns. Put is here's a bunch of columns, stick it at this row key. And then scan is start at row X and then go forward in the sorted order until row Y by primary key. So it's essentially all of the primary key operations and not a whole lot else. There's some filtering capability, obviously, in scan also, which we'll get to later. In terms of security, it obviously depends very much on the database, what sort of security it offers. Right now, HBase's security story is pretty much not there. There's a team working on it at Trend Micro, which is a large antivirus and security company. So I'm happy to say it'll be coming very soon down the pipe with full Kerberos authentication. In terms of indexes, I've mentioned this a little bit. The indexing in HBase is essentially primary key indexes only. And if you're familiar with the term clustered indexes, the primary key is a clustered index, meaning that the data is stored in primary key order on disk, which is great that you know that. That's always true, because then when you access a primary key, you know that the next primary key in the table will be on disk right next to the first one. This goes back to the cost transparency idea, is that you don't have fragmentation. It's just not a problem. Whereas fragmentation in a typical relational database can be a pretty big problem. You end up having to reorg your tables at midnight or something like that. In terms of the data size I mentioned, in terms of HBase proper, I don't think anyone's hit the petabyte mark yet. Bigtable, which has the same architecture, has hit the petabyte mark long ago at Google. So there aren't any fundamental limitations. It's just that nobody has deployed at that scale yet. I'm pretty confident that we'll have people at petabyte scale within the next 6 months. In typical relational databases, there are some exceptions, clearly. Generally excel in the terabyte or even sub-terabyte scale. And if you pay enough money, you can get to the many terabyte scale, but you'll pay a lot of money. And then in terms of throughput, it's the same thing. You can scale out the throughput by adding more nodes, and you can get to millions of operations per second as long as your network can pump the operations in and out. So a lot of people ask, there's HBase and there's Hadoop. What's the difference? How do they connect? Essentially, HBase is built on top of Hadoop. So Hadoop provides a great platform for having distributed fault-tolerant systems in terms of storage in particular. So HBase requires HDFS, the distributed file system component of Hadoop, And it can work with MapReduce, but it doesn't actually build on top of MapReduce. MapReduce can access it. So in terms of what it gets out of HDFS, it pulls fault tolerance, scalability, and the batch processing integration from MapReduce. So in terms of fault tolerance, it's pretty clear. The idea is that when you have a lot of machines, maybe 200 machines, it's likely that on any given day, one of the machines is acting up. Either its disk's filled up from normal operation, you didn't catch it in monitoring, or hardware died, or something went wrong. And the idea with Hadoop is that it'll deal with that in a general case, and just ride through it. You don't have to be woken up at 2 a.m. because one of your 200 machines died. You can deal with it the next morning or whenever you next get to work. And scalability, it provides a great platform that has been proven at the petabyte scale at a number of organizations, so that you're sure that the underlying platform is well tested, it's very robust. Across the world, there's probably over an exabyte stored in Hadoop. You don't have to worry that it's going to go lose your data, things like that. So I just talked about how great HDFS is. Why do we need HBase if HDFS is so great? HDFS, as an API and as a system, only provides sequential I/O, sequential writes. You can't go and update the middle of a file. And a lot of people think this is a huge limitation. And in some ways it is. The thing is, that is why HDFS is so scalable and so stable, is because it's chosen a simple core and says we can do this well, and we're not going to try to do a bunch of other stuff. So HDFS provides the streaming I/O, and HBase adds on top of it the ability to randomly access the table in very efficient ways. So particularly, you can random read at any row in a table. You can random write at any row in the table. You don't have to do any special machinations of your own to achieve this on top of a sequential write-only system. So the way it does that, we'll talk about it more in a little bit. Essentially, it converts all of your random writes into a log, and then occasionally merges that log back into the table. So if you're familiar with log-structured file systems, it's essentially the same thing. There's a paper from '89, I think, about log-structured merge trees, which is sort of the foundation of this idea. Yeah, it's actually a very similar idea to the name node. The name node writes all of its edits, and then the secondary name node picks up the edits, merges them into the image, and then writes out a new image. So this is essentially the same thing, a little more complicated. We'll talk about it in more detail in a few minutes. So earlier I mentioned some of the use cases in terms of general ideas. Why would I want HBase? Here are a couple of specific use cases and specific examples of HBase being used. As I mentioned, HBase and Bigtable are somewhat interchangeable in terms of architecture. So even though the implementation is not the same with Bigtable, I think it's good to say, well, this is the architecture, this is the API, and it's been very useful at Google. So you can assume that for similar kinds of applications, it'll be useful with HBase in the open source world or your company. So at Google, it's used for hundreds of applications. A couple of them are known to be Google Maps. Gmail uses it for some aspects of its storage. Blogger, all of the blogs on Blogger are stored in Bigtable. I don't believe YouTube videos are stored in Bigtable anymore, but at one point they were. And they're, I think, stored in a system on top of Bigtable now. And many more. Calendar uses it. The Google App Engine data store is built on Megastore, which is built on top of Bigtable. So it's generally a very useful infrastructure component that's proven itself for many, many years at Google. And then in terms of HBase specifically in production, there's a powered by page on the wiki if you want to check out a more complete list. Just a few of them. Yahoo uses it for some analytical workloads inside one of their teams. StumbleUpon uses it for the su.pr URL shortener and a bunch of analytical use cases. And they're actually looking to move more and more of their site off of MySQL onto HBase. Trend Micro, I mentioned earlier, is a large security company. They're building a sort of cloud storage platform for internal users based on HBase. A few more: Ning, Meetup, Adobe, GumGum, Flurry. Some of them are Web 2.0. Some of them are larger companies like Adobe and Trend Micro, which is a public company. So just to sort of wrap up this chapter, we talked about what HBase is, why you might want to use it, some usage scenarios and a general idea. And then we sort of compared it to relational databases, particularly in the sort of MySQL Postgres, but also somewhat applicable to comparisons with RAC or DB2 or Teradata, things like that. And then how it complements Hadoop, how it builds on top of Hadoop, and how it's different and why you should use it instead of just HDFS. Or maybe if your application doesn't require these things, just use HDFS, then you should be okay.